Well, Greg, thanks for being here today. You're a paleoclimatologist. What on earth is that?
A paleoclimatologist is someone that looks at what climates were like in the past. And by in the past, I mean before we started collecting climate data using instruments such as thermometers and barometers, etc.
Tell me a little bit about the research you're doing.
Well, what we're interested in mainly is investigating past variability in climate on a longer time scale than weather, the Bureau of Meteorology weather predictors would normally look at. They look at windows of about 30 years or so, and all that tells you about is how much variability there's been in the last 30 years. If you want to know beyond that, then you have to look on a much longer time scale.
So essentially, are you a little bit like a weatherman?
I'd like to think that I can contribute to that overall story. The weather reports that we get on the radio and the television on a daily basis actually come from the Bureau of Meteorology, and pretty much all they're doing is looking at the weather patterns developing in the short term. So they can predict 2 or 3 days in advance, maybe up to a week in advance by looking at those weather patterns. But beyond that, if you want to start predicting months in advance or even potentially years in advance, then you have to start modelling the system, or at least knowing what the total variability in the system has been in the past.
So you're also looking into El Nino. Tell me what it is specifically that you're looking at.
My El Nino research started off by looking at sediments along the coast of New South Wales, essentially. I started doing some work in Mile Lakes, and we had a nice record there going back about 20,000 years. And everybody sort of assumes that because we have these wet and dry periods, extended wet and dry periods in Australia, that they're caused by El Nino. And we found evidence for extended wet and dry periods in those sediments, but they were on the order of hundreds of years rather than what we normally think of, tens of years or even less than that, when we're looking at today's weather patterns.
So are you saying that we can predict the future by essentially looking at the sediments of the past?
The climate as we experience it today is a result of movements in the ocean and movements in the atmosphere. In fact, it's a linked system. The atmosphere moves as a result of incoming solar radiation, and as it starts to move, it drags the oceans along with it. The particularly good thing about the oceans is that at the time that the climate is manifesting itself, we collect information. Little animals that live in the surface of the ocean secrete some of their shells, and that contains a temperature record of the seawater at the time that they formed their skeletons. And so what we get is a record of sea surface temperature variation and other information as well, in the correct order that those climates occurred in.
What kind of technology do you use?
The technology is pretty straightforward, although in many cases it's very expensive. I mean, we go to sea, we stick a cylinder that looks a bit like a drain pipe, except it can be up to 6 kilometres long, into the sediments on the sea floor, and we pull that back out again, and we have a record. It's almost a tape recording, if you like, of that past variation. Then we collect samples of that material, and we run some sophisticated geochemical tests to extract this temperature and other climate variable information. So as long as you can afford a very large ship at about $40,000 or $50,000 a day, and you have enough days and enough people to do this work, then it's a really simple concept.
So that must involve some pretty exciting field work. Can you tell me a little bit about that?
I've been to sea, let's see, on 4 occasions now. The cruises that you go on last up to 2 months, so 60 days at sea. I've been on a leg in the Western Mediterranean, then I went on a leg in the Eastern Pacific from San Diego to Santiago, and we actually ran a cruise year before last for postgraduate students, sort of a training cruise, which was We went from, let's see, New Zealand up to New Caledonia and then back to Sydney on that.
What are some of the challenges that you're facing from a research point of view?
Oh, well, the challenges in the research are essentially there's not enough money for everybody to do what they want to do. I mean, that's always the big problem. There just doesn't seem to be enough money, particularly in Australia, but in research globally in general.
Well, thanks so much for spending some time with us today. Sounds like you're doing some really important work.
I hope so, but it would be nice if we could get more of a larger community involved in Australia in this, what I believe is this important area.